Jack Young, thank you so much for joining us today for another Machine Heads interview, man. How are you?
I'm doing good, Wayne. How are you?
Good, man. Can't complain. Ready to talk about some CTL machine control. You're the perfect guy to talk to from Trimble on that. You are the machine control product manager at Trimble. And so, to kind of get us started, you guys have a new product that we're definitely going to talk about and get into. But first, we're going to kind of set some context for not just kind of like this all the machine control kind of options and that you guys offer for compact track loaders today. So we'll get the market kind of settled, and then kind of your traditional options, and then we're going to get into this new product that you guys have. That's pretty exciting. But let's start with an overview for demand for grade control technology on this machine type, the CTL in particular. It's been around for, about 20 years now in general, the technology. And then on the CTL, it's been around for a while now too. And then, I feel like about 10 years ago, you started seeing some renewed, not even renewed, but just kind of some new interest from kind of like from the first party, from the machine manufacturers themselves, kind of offering some really interesting CTL configurations, maybe with a dozer blade, but then also some kind of like integrated machine control on them. And so the main point here is that, over the years, as CTLs have become more and more kind of in demand for contractors, they want to do more stuff with them, and among those things is grading. So give us an idea from Trimble's perspective, how demand for this technology on a CTL has evolved, and where it stands today.
Yeah, absolutely. I think it's a great question. I mean, as you stated, machine control technology has been around for some time now, and I think primarily the dozer, motor grader, excavator market has been kind of the key focus of our customers and our dealers around providing technologies to increase the productivity on those machine types. And what we're starting to see is that contractors, instead of buying a small dozer, as compact track loaders are getting more and more capable each year, I seem to, in the last 5 years, it seems like every manufacturer in the market has released their largest compact track loader yet. And we're starting to see that, your typical Swiss Army knife mentality, that bringing in a compact track loader and equipping it with grade control technology or an attachment that could do what, a small dozer could do or a small motor grader could do, is starting to become the preferred choice for contractors. And with that, just like contractors are using that machine in situations where the larger machine could have been used before in the past, they're starting to look for the grade control there as well, right? So traditionally, these compact track loaders, for anybody that has ran the attachment or even the bucket, they tend to be some of the harder machines to operate out there. So where contractors might take a dozer and put some 3D grade control or 2D grade control on it to spread material or get that work done on their job, the compact track loader is starting to be the preferred choice. And we're starting to see the compact track loader and the mini excavator taking the place of what a backhoe loader used to do. And so as the machines become more capable, we want to provide grade control solutions to meet the customer where they're at.
Yeah, absolutely. And give us an idea of the types of jobs that you guys are typically seeing, grade control equipped CTLs kind of being used on. You mentioned kind of like how the preferences have shifted in terms of machine type. Obviously, like that, the backhoe has kind of gone out of favor, and preference for something more like a combo of like a mini excavator and a CTL, like you mentioned. But what are some more specific kind of examples of jobs, and maybe even industries, or whether it be kind of like site prep or residential, where are you guys really seeing CTLs with grade control used most at?
Yeah, I mean, it's always, you see them almost everywhere, right? If you drive around, you go grocery shopping, you'll drive past a job site and see a compact track loader sitting there on the job. But some good examples of that are, sports arenas, parking lots, residential. We see it a lot in the residential market. Um, but really, the driveways on residential are for spreading materials, are used often, where you have a truck dumping material, grab it with a compact track loader and spread that material around, and try to get close to grade and come finish in with a compact grading attachment. But really, general surface preparation. So if there's any surface that's prepped for asphalt or concrete, oftentimes the smaller machine can come in and spread that material around on those tight jobs where you're not doing like a large scale road or highway or airport job. And you're in tighter corridors where the compact track loader has a ton of flexibility to get around and spread that material. So the easy answer is you pretty much see it on every job, even the large jobs. There's always cleanup work on the sides, sidewalks, things like that, where the large machine doesn't necessarily make sense to bring in to do that small, the smaller jobs on those job sites. But the utilization, I mean, we see that the growth of the just using these machines on the jobs climbing year over year, and they're really everywhere.
Yeah, absolutely. And so we're going to get into this a little bit more in depth in a bit in terms of just kind of what the technology typically applies to. And we're typically talking about an attachment. And so before we do get into that, could you tell us like what types of attachments? I mean, I know that you can put a motor grader type blade on these. You can put box blades. You can put, dozer blades on these. I mean, what is maybe the most popular attachment type that you guys are seeing grade control used with on a CTL right now?
I think the grade control conversation really started around the box blade initially. Box blades were really, really good because they have wings on the sides, hence the name of the box. They can grab the material and pull it with the CTL, which I alluded to, the spreading of material. That's a really good tool for that job, where you can, truck dumps whatever material you need to spread it. It grabs it in the attachment and spreads that across the site to the grade you're chasing. Kind of the key request when it came to grade control is like, hey, this is a great attachment, but it's a small platform. It's jumpy. It's not that stable. I'd love to have some automatic control here to help me out. And we've seen that manufacturers of the attachments have released more grader blade type attachments that have rotation as well. And with the introduction of the wings on the sides of the grader blade attachment, you kind of have an attachment that does both material spreading and carrying of the material, but also you can open up those wings into your final pass and windrow to the left or right and rotate your blade. So it kind of started with the box blade, and we're starting to see more and more grader blade type attachments becoming the preferred choice for contractors. And in the last few years or so, the dozer blade has really taken off, especially when you are loading the blade with a lot of material and really wanting to, with the horsepower increases that compact track loaders are starting to deliver to the market, customers are wanting to get those wheels out of the way, right? Because there's always wheels out in front stabilizing, and the request to get them out of the way so I can push material. They keep rolling over the top of pipe. I'd love to just have a dozer blade so I can use this instead of having to bring in a small dozer. So each attachment type kind of serves a different purpose, but the motor grader blade and the dozer blade are really starting to become the core requests that we see from the field.
Yeah, I mean, and that makes sense. I mean, those are kind of like the more specialized tools, whereas the box blade kind of felt kind of like we're kind of making do with what we have, and it just made the most sense with that version of the CTL. And the CTL as a platform has really evolved in a huge way over the last like 5 to 10 years. And then as you guys kind of like look at demand for grade control technology on CTLs, initially I was kind of like thinking, like, do you guys see that kind of like continuing to grow? I think obviously it's going to continue to grow, but how do you guys see what's happening right now that kind of gives you like, oh, I think that right now, like just a second ago, you mentioned kind of like the evolution from like box blade to grater blade to dozer blade. What are some other maybe trends that you're seeing in how this technology is going to continue to grow, or maybe the way it's going to be used as you look toward the future? How do you see it continuing to evolve as more and more contractors use the technology for grading?
Yeah, I think at least from Trimble's perspective, one of the things that we're really aiming to provide to contractors, and instead of just, hey, I'd love to have my compact grading attachment drive to a 3D model or a 2D surface, I really want to have that point-to-point solution that if I'm bringing in a file, I'd love to be able to do data prep on my site without having to call surveyors all day, without having to tap into an office. That's not really, this is a 1-month-long job. So for us, we're really trying to provide a kind of a one-stop shop for contractors that the machine's important, but there's a lot of other things that happen on that job where, we want to help the contractor increase that productivity. So that's one big piece of it. The other piece is pretty much every time you have grade control on a machine, you typically need some sort of positioning technology off of the machine. You see this on a laser job with a laser transmitter, and contractor walking around with a grade rod checking grades across the site. So we've introduced technologies that allow that same grade rod to be used by the grade checker across the site, but then also use laser transmitters on the attachment So that single laser transmitter plane can be used on and off the machine. As 3D has become more popular with our customers, we want to deliver that same value in the 3D site, such that you can use technologies both on and off of the machine. If you have a 3D technology on the machine that you are, driving to some sort of 3D model, if we can provide that contractor the ability to continue to use that hardware and those tools off of the machine, except that they can continually get that ROI and use that, get the utilization out of the system, we want to do that. And I think that's a big trend for Trimble. And we're starting to see that in some of the other offerings we see in the market too.
Yeah, absolutely. And now let's dig a little bit into maybe the more traditional kind of. When I say traditional, it's really just kind of been basic, and the new product you guys have been working on is kind of an alternative, but it's really kind of like what you were just talking about, trying to meet kind of more contractors where they actually are. But traditionally, there's been, when it comes to grade control on any machine, but obviously CTLs as well, there's 2D grade control and there's 3D grade control. For folks that maybe don't know the difference, or they haven't used these types of things in the field, but they are interested in, researching or maybe even eventually investing in grade control on a CTL, take us through the differences between 2D and 3D. Because they're really, it's not like one is necessarily better than the other. One might be more fully featured. 3D is more fully featured, but there's a lot of instances where all you might need is 2D. So take us through those differences.
Yeah, absolutely. No, it's a really good question. I hear that all the time at trade shows and when I'm out on site with customers when they ask questions about grade control, because it's a pretty big decision deciding to go 3D or 2D. And when we have plenty of 2D solutions and offerings, and they're not going away, it's still a very relevant product and solution for many customers. It's really more, to your point, about, hey, I know these technology solutions out there. Which one best applies to the work that I do? And for 2D, really, the machine doesn't have any idea where it is in space, right? It effectively knows it's sitting there on the ground, and there's some flat surface, whether it be from a laser transmitter, shooting a flat laser pad or a laser plane, excuse me, or a sonic sensor that's giving you a distance to a string line. All it knows is that it's here and it needs to be here. It doesn't, from an elevation standpoint. So that's great for flat work. You can imagine flat planes if it's a flat pad for concrete prep. If it's a sloping pad for drainage on a slab on grade, something like that. Where you're just doing flat work. 2D is very, very well. If you're tracing a string line for, to match a curve, something like that, where you don't care where you are in the world and you're not running off a 3D model, 2D is really good for that application. It's highly accurate and really easy to set up and get working. We have products like Trimble Earthworks Go is a really good example, or Trimble Earthworks is a really good example. That also we leverage our LR410 laser receivers on the attachment. And that effectively catches the laser and tells the blade where it needs to be. When it comes to 3D, the machine actually has a known position in the world or on your job. And when you have that ability, you can do the data preparation, import that into the machine, and now the machine knows exactly where it is on that job site and how far it is from the final grade that you're targeting in that location. Now, this is really, really good for a lot of applications. Complex jobs, absolutely. 3D is a no-brainer. And when I say complex, any sort of planes that are sloping up and down, you think golf courses, any sort of like landscaping where you're not just making perfectly flat pads, roads that are going up and down, sidewalks, really anything that's not flat, right? The 3D technology is a huge time saver. The big thing with 3D technology is there's a little bit more data prep needed beforehand because the machine needs to know where it is. We at Trimble want to provide as many tools as we can to a contractor to achieve that goal. We have, you could either get the positions from a surveyor, you could get it from the design engineer, you could get it from a plethora of places. But that surface gets imported into the machine, and then the machine is able to guide to where it needs to be. But we also provide tools in Trimble Earthworks, for example, which is our premium machine control solution. We call it in-field design, where a contractor can show up on site. They haven't done any data preparations. They're not contacting an engineer. It might be a short-term job. They're only out there for a month. And they can actually create some lightweight designs from the cab itself, which gives the operator or the foreman or whoever's planning the site the ability to then not have to call a surveying company, not have to call a design firm, and you can effectively do everything the 2D system can do. You could do flat pads, you could do sloping pads, you could do sectional alignments, which is effectively road corridors, all from the cab. The other thing that we've started to we as Trimble see all the benefits, of course, in moving a customer into 3D for various reasons. With the introduction of the product we've been talking about, kind of a new product that we've added to our ecosystem, Siteworks Machine Guidance. We've taken our site layout technology that you might find a contractor using to lay out positions on their site. Then we provided the capability to take those key components, the survey receiver and the tablet that's on the rod, and take that off the rod and mount it on the machine. I alluded to this a little bit earlier, but this is kind of a trend that we're trying to lean into to provide a one-stop shop and an entry point for contractors into 3D. Because at first glance, it seems it can be a bit intimidating, but more and more we're developing solutions specifically targeted at contractors that are trying to make that buying decision.
Yeah, absolutely. I mean, and I think too, like another kind of question that comes along with like the 2D, 3D debate, it has to do with the obviously like to get that position in space that really kind of differentiates 3D from 2D. It requires different equipment and stuff like that. So could you give us like an overview if we're just talking about 3D? What are kind of like the necessary components of a 3D grade control system for a CTL? Another question usually is kind of like, are masts always necessary? Are they still necessary? Obviously, there's some integrated systems now, but when we're talking about like a third-party CTL system, give us an idea of the components that you need, and maybe even like how that differs. Like what is on the 3D system that you just don't need on the 2D system in terms of stuff that you're going to have to put on the machine or on the attachment?
Yeah, so the first thing that every 3D system you see anywhere is going to have some sort of receiver that is going to give you that 3D position, whether that be via GNSS, which is via the satellites, or an optical target, which is via total station. We need some sort of receiver that's going to get us that position in space. The most common functionality that you'd see is with the satellites. And that GNSS receiver not only gives us the position in space locally on the machine, it also communicates with some sort of corrections source, which anybody that invests in 3D will quickly learn what a correction source is. But effectively what it is it takes your accuracy from what you might see on your cell phone, 10 feet left and right radius, down to that golf ball target that we're trying to get to for that high accuracy positioning. And what the correction source is, you can do it whether you run a base station, which is putting another receiver on a known point on your job site, and that communicates with the machine to tell it where exactly it is in space. But there's also other sort of correction sources out there that are provided by the local municipality through the internet, or even Trimble provides our RTX center point positioning service, which actually uses a satellite in space as your positioning source. And in that case, you're just turning it on and you're up and running. But every single 3D GNSS system is going to require some sort of correction source. So that's number one. Once you have that, it really depends on what kind of system you're running. So on the attachment, we as Trimble elected to pretty much always have masts on the attachment. And the reason for that is that if that compact track loader disconnects from the attachment and another compact track loader comes in and interfaces with that attachment, the entire system lives on the attachment itself. And that makes that attachment grade control ready. But with that, we've also, the Siteworks Machine Guidance product, we've introduced the ability to take your survey rod, which also would connect to a base station or some correction source, take that off the rod and mount it on the lifting arm of your compact track loader. And that actually provides 3D indicate guidance to the compact track loader bucket. So the compact track loader, every single one has a bucket. Almost every single job site has a compact track loader. So when we talk about 3D entry points, that was the goal. Let's meet the contractor where they're at. They walk into our Trimble side tech dealer and say, hey, I have a compact track loader. I'd love to have some sort of guidance to it. What do you have? The entry point with Siteworks Machine Guidance and the value proposition is hey, you have a 3D survey rod that you can use to lay out anything on your job site, but you also have the ability to take those components off, put it on your excavator or your compact track loader, and get bucket guidance for when you're sitting in the cab. The attachment is usually where we see the automatic grade control come in, and the bucket is where we're delivering that indicate guidance with the Siteworks Machine Guidance system. Across the board, all of them are going to have a 3D positioning device, and that's usually in the format of a 3D receiver.
Gotcha. Okay. Yeah. So, I mean, let's drill down a little bit more into the Trimble Siteworks Machine Guidance module for CTLs. This, again, you guys announced this very recently, just here within the last couple of weeks, and it's Trimble's first machine guidance solution for CTLs. But it, again, as you mentioned, it's not being designed, or it wasn't designed for primarily for use on a blade, because it's that modular solution that you really kind of we're going into there. This can be used with a bucket. Tell us a little bit more about it. It sounds like it's a because it was first kind of made available on excavators, like you mentioned. Is this system? Does that mean that you can like you said, can you take this off a CTL and put it on an excavator, and take it off the excavator and put it back on a CTL? Because you guys have basically just kind of expanded support for the module to add this new machine type. Tell us a little bit more about the module and kind of like how it works, and maybe like you mentioned, it's kind of like an entry point into 3D, because it sounds like it doesn't have all of the components that you would need for a fully 3D system. How does that work? Like, let's say you do want the positioning. This does sound interesting, but you're just really going to be doing mainly bucket work. You do like the ability to move it between the machines. How does it work? And then if you do want kind of like the full 3D experience, how does this integrate into kind of like a fully 3D system?
Yeah, no, that's a really good question. If we kind of start from the beginning, Siteworks Machine Guidance is built on Trimble Siteworks, which is our core heavy civil construction job site layout survey solution. So it's kind of a one-stop shop for all things 3D positioning on a job site. And you see it in the format of a survey rod with a receiver. Specifically, the Siteworks Machine Guidance system uses the Trimble R780 receiver, which has fully tilt compensation in it. So what that means is that once you have that rod in your hands, it doesn't matter if it's straight up and down. It will always tell you the position at that rod tip. And really what we did was we built functionality on top of that tilt compensation positioning that we released, such that a contractor, I mean, we hear this time and time again, contractor comes into our SciTech dealer and asks, hey, I would love to move into 3D, but what do I do first? Do I get a survey receiver like the R780? Or do I go and buy a 3D machine control system? And that decision, we didn't want the contractor to have to make if they're not looking for a full 3D system with automatics. I mean, that's a big decision. And if you decide to go down both, it's a big investment for someone that's just looking to get into 3D. So what we decided to do is leverage the ruggedized 3D tilt compensation receiver that's used on thousands of job sites across the world for all that site positioning, and add the machine guidance module in Siteworks so that the customer can continue to use that tilt compensated ruggedized survey head on their machine from in the cab. So they can unscrew the receiver, pop the display off the rod, mount it in the cab of the excavator or the compact track loader. You can do either, or you can move the system back and forth, and then click the display in the cab, and you have now transformed the positioning from the rod tip to the bucket tip. You're able to, it's fully dynamic, so it doesn't matter what machine the machine position is in. If you're on a slope, forward, back, left, right, doesn't matter. And it gives you that position at the bucket tip. You can do a focus point in the left, center, or right of your bucket. And then when you're done doing your work on the machine, you can switch it back to standing mode, take the components and put them on your rod, and continue using it boots on the ground outside of the cab. So when we talk about entry points, we're really trying to drive that value proposition that this survey receiver never ends up in the back of your pickup truck because you're not using it. And the system will carry with you, whether you're walking around finding building corners with the survey rod, or you're in the cab trying to dig a trench to grade. The same system is being utilized in both places. Now, you mentioned, okay, I invest in Siteworks Machine Guidance and I love the system, but I really want more out of the machine control side of things. That's where our premium machine control system, Trimble Earthworks, comes into play, where we do a full sensors all over the machine. The receivers move to the back of the cab, and we can deliver full automatic grade control. The nice thing about that upgrade path is that most customers we have today that are using the full 3D Trimble Earthworks system on their machine also have that survey receiver in their fleet. So the functionality that the R780 and Siteworks deliver are still very much valuable and prevalent to a customer, even if they decide to upgrade out of that system.
Gotcha. So, kind of listening to your explanation of kind of, it sounds more like, so it kind of lives between 2D and 3D in the sense that there is a 3D upgrade path using this same equipment and the same kind of platform. But then on the 2D side, does the functionality that you get with kind of like the positioning aspect this adds, does this give you kind of like an alternative to 2D grade control with like similar functionality? I mean, is there like a grading component to the machine guidance module, I guess is what I'm asking. Could this be an alternative? Like instead of going with a 2D solution, you go with this, and then this also gives you an upgrade path to 3D. Like how would you, what's the difference between the 2D option and then this module?
Sure. I think the big piece of that and the decision making around that purchase and what solution is right for the contractor comes down to what sort of value you're looking for. I think if a customer is, I have a compact track loader, I have a grader blade, and everything is great, except I'd love to have some automatic control of the attachment because it's very difficult to control manually, and I'm cutting out really, precise flat pads for concrete prep. A 3D Siteworks machine guidance system might not make sense because it has no automatics. The Siteworks machine guidance is there just to provide visual indication to the operator. So the 2D, 3D discussion is one piece of it, but the other piece is, do you want automatic control? So for a customer that's, primarily doing residential or, utility work, and they don't necessarily need automatics, they're oftentimes switching from their compact track loader to clean up work on the sides of their job, into their excavator to dig out over dig on a foundation basement or, digging utilities. And they just want to know they're fully manually controlling a machine, but they'd like to know where their bucket is in reference to even a PDF design or a 3D model, or some line work that they actually drew on the site themselves. That's where Siteworks Machine Guidance comes into play. They're not looking for automatic control. They just want that visual guidance. They want that light bar. That's where that system really delivers value. If you're looking for, hey, I don't really need to know where I am on my site, I just want my cutting implement to be controlled automatically, that's where maybe 2D automatics make more sense. So I would encourage the customer to figure out where they're looking for value addition from technology. Is it just, hey, I'd love to have some guidance on my site of where my bucket is so that I can not have to rely on somebody outside the cab to tell me where to dig. And I'd like to have that information in the cab. Am I actually looking for, I'm doing flat work, sports arenas, and I just want to have some automatic control to smooth out my operation and create those flat pads faster. It really depends on what sort of work you're trying to accomplish. And this is really why we lean on our distribution partners. Our side tech dealers are absolute experts on applying our technologies to what the contractor problems are. So we have them in everybody's neighborhood, and they're kind of the experts on, hey, what kind of work are you doing out in the field, and how can our solutions apply to your jobs?
Yeah, I mean, it kind of sounds like, and again, like on the spectrum of kind of 2D to 3D, it really sounds like probably the module, this new Siteworks machine guidance module, is more akin to maybe like a more advanced version of like 2D indicate, where basically the machine is just kind of telling you your angle or your slope or whatever. This is like, this new module is almost like a souped up indicate, where you're not getting any kind of like automatic control, but you are getting kind of like that really precise kind of like position to kind of give you an idea, like a visual marker of kind of like where you're at on the site, or kind of like where you're at in terms of like the slope or the grade and everything that you're trying to
100%.
achieve.
I think that's
Okay. Yeah.
a great way to describe it, because really it gets confusing, but at the end of the day, there's 2D indicate and automatic. 2D is kind of, what are you driving to? Is it a flat plane or is it a 3D position in space? There's indicate and automatic for 2D, but there's also indicate and automatic for 3D.
Okay.
So Siteworks Machine Guidance is that indicate for 3D. Hence, it's that entry point for 3D where I want to come in to use 3D models. And you can do 2D planes, you can do flat pads, you can do all of that in Siteworks Machine Guidance as well. But it's not going to control your machine for you. It's really there to give you that indication in the cab and then be able to take it off the cab and continue to use it for using, to get that information on your job site.
Yeah. Yeah, it sounds like it's 2D plus, right? So you can do 2D if you want, but then you can do 3D indicate as well. You just can't do
Yep.
the automatics. Yeah. Cool.
Yes, exactly right. Yep. So
In
we're really
terms
excited to
of,
get that one out there because we hear a lot of contractors all the time are asking, hey, I don't necessarily need automatics, but I need more than what 2D is giving me. How can
yeah.
I get into this? And that's really where that product comes in and provides that across the fleet utilization. And we have products for the far right bookend and the lower tier where, hey, I want 2D automatics. There are products like Trimble Earthworks Go. And if you want full 3D automatics or 2D automatics in our premium platform, then Trimble Earthworks is there as well. So there's points along the customer kind of growth path. Our goal is, we talked about demand early on in our conversation that more and more contractors are looking for their way into technology. We want to provide those points for them to come in and get the ROI immediately.
Yeah. So if we're talking about, without getting into like specifics on pricing and everything like that, but in terms of like what is the premium, I guess, of like 3D or 2D with automatics over just the module, this 3D module?
Yeah, the premium. So our premium grade control solution is Trimble Earthworks. So Trimble Earthworks is fully integrated with the machine. It's got full 3D automatics, but it also leverages any sensor suite that Trimble provides. So you can run 2D laser, you can run 2D sonic, you can run 3D total station, you can run 3D GPS. And so Trimble Earthworks is really our core machine control solution. Trimble Earthworks Go is our lightweight version of our premium grade control. So Trimble Earthworks Go comes in a briefcase. You can flip it open, magnet mount everything on your compact grading attachment, and you still get automatics, but it's only 2D. The kind of interim, kind of what we've been talking about between the two is a lot of contractors are looking for, okay, the machine piece, that's great. Machine piece is great, but that's not everything I do. I need to know where the corners of the building are. I need to capture surfaces. I need to check grade, all while outside the cab. That's where Trimble Siteworks comes into play. And that's why we wanted to add that module into Siteworks so that the contractor wouldn't have to take that big jump into machine control if they weren't ready for that.
In terms of like how the pricing kind of stacks up, I mean, how does it stack up in terms of how much more, I guess, kind of expensive it would be to how much are you kind of saving by just kind of doing something like the Siteworks Machine Guidance module? Like, is it like is it
You're
50%
saving a
of
lot.
the price? Yeah. Okay.
Yeah, you're saving a lot. So effectively, before Siteworks Machine Guidance was available for contractors, the choice was effectively, do I buy a 3D rover and a 3D machine, which is, that's a lot of, it's a sticker shock, or do I buy a 3D rover with a 2D machine and have some lightweight machine control? That decision was very difficult to make. So if you think about the Siteworks Machine Guidance module, it's kind of a 2-for-1, right? You're getting that off machine functionality, but for a pretty inexpensive add-on, you're adding the ability to put it on your machine for lightweight machine control, which is effectively indicate machine guidance, at that 2-for-1 price tag. So it's a really good, if you're looking for high utilization and the features and functionality are right for you. It's a really, really good feature pack solution.
Yeah. I mean, it seems kind of like yeah, if you know that you're not interested in automatics right now, but you are interested in automatics someday. I don't know. It feels kind of more like you said, that there was a very almost like a black and white. Like, I'm either going to do 2D automatics or I'm going to do 3D automatics, and some of the 2D systems would kind of let you kind of upgrade to 3D. This seems like for people who really, really don't know and are just trying to dip their feet in the water. There's like a clear upgrade path. There's just kind of like very few compromises that you're having to make with this system.
Absolutely. I don't think if you upgrade through the path, you would never really get rid of any of the solution. It's all part of the upgrade path. There's nothing you're going to throw away or get rid of as
Yeah,
you
that's awesome.
climb your way through the technology.
Yeah,
journey.
making the most of that initial investment for sure. I do kind of want to finish up kind of talking a little bit about workflows and maybe the machine itself and kind of like buying considerations. We just talked a little bit about some of the decision making around ROI there, but if you do go and I am kind of interested too in kind of hearing kind of the workflow around the new machine guidance module as well. But take us through the typical workflow of using a 3D system on the CTL, and maybe include some discussion there too around the machine guidance module, because I know that that is a piece of the overall 3D system. But yeah, from someone who's never done this before, kind of take us through quickly kind of like what it looks like setting it up, and then getting the design files onto the machine, and then actually operating the system in the field. What does it kind of like look like to actually, put this into use for those that have never experienced it?
Yeah. So it's a really great question. That's typically one of the most intimidating things for most, contractors when they're looking at the technologies. It's a workflow change. When you purchase technology and start to want to use it on your job sites, you're not going to be doing this things the exact same way as you were. Where you were out pulling tape measures and laying string lines, that workflow is no longer needed when technology is there. It depends on the kind of job that you're running. If you're on a large job, typically the engineering firm or the engineer that is, actually designing that model, will typically provide that to the contractors. And whether the contractor themselves are actually taking that model and cleaning it up to be used on the machine, or they're working with a third-party company that does that for them, that's usually how that data is prepared to be put in the machine. And at that point, it's just put it in the machine, turn it on, and get working. And that's typically on those longer duration, larger jobs where a 3D model is pretty much, it's, an engineered site where it's there every time you do one of these jobs. Now, on the short jobs, that's where things get a little bit different. The shorter, small, kind of residential type jobs, where leveraging either a surveying company, or doing it yourself to come out to your site and lay out building corners, or set your own control points. Like every day, these control points, these are not going to move. I can check into these to make sure I'm accurate. But then you have the ability to bring in a PDF. I mean, every contractor has a PDF design of a basement foundation. You can bring that into Siteworks and stitch that right on your job site. Now, instead of walking around with a paper in your hand trying to figure out elevations and where building corners are, all of that is then imported into Trimble Siteworks, and you can use that to actually build the lines of the foundation, offset it out for your overdig, chase the elevation that you're trying to get at the bottom of that dig. You can use it to find if you have an elevation and position of the city water connect, things like that. That's all inside in the solution. So I guess the message I'm trying to drive is that whatever information you are provided for the site, you can either import that or create your own, whether it comes from a PDF or a 3D model. All of that can be brought into the technology. And once you're set up, it's all displayed in the cab. So yeah, it's there's definitely a learning curve to it. I'm not going to lie, but like I said, it's changing your workflow. But upon purchasing any Trimble technology, that our network of SciTech dealers are there to provide that training, that are there in your neighborhood to be boots on the ground out on your job site to help you get that workflow up and running so you can become self-sufficient on your own.
And beyond kind of like, ROI and things that would, take actual kind of like consideration of kind of like how you're using it or how often you're using it, and the initial investment, price that you're paying and all that good stuff. Apart from that, what are some of the real world benefits that, I mean, I've talked to lots of contractors, from guys that are 50 to 100 million a year to guys that are around the 5 to 15 mark, who who are guys that used to be closer to the under a million mark in revenue a year, who have adopted this technology. And then it described exactly what you just said, kind of like the adjustment period and maybe some of the intimidation. But what they all agree on is that once they adopted the technology, it was just kind of like a mind shift change in terms of what was possible, the accuracy that was possible. And then typically what would follow too is the types of jobs that they were able to bid on would open up in a big way. I mean, obviously, like over the years, you've seen kind of like lots and lots of DOTs. When it comes to machine control, like, any kind of like contractors that they're going to bring in to kind of like what they would start to kind of like require, if you're going to bid
Right.
this job, machine controls. So for on the CTL side of things, what are some of those kind of like real world benefits that you're immediately going to kind of see once you kind of take the plunge and you get used to the workflow changes, you swallow that initial kind of maybe costly investment if it's like a 3D system? What are some of those benefits that are really kind of like change, business changing for the guys that do take the plunge?
Yeah, I think one of the big ones that's pretty easy to talk about first is the distribution of labor on a job site can be done a lot more efficiently when technology is given to a contractor. Once you do get through that growing pain of kind of adjusting your workflows and reallocating how things are done, all of that information that a contract or that an operator would typically have to get from outside the cab, whether it be, stakes in the ground by calling surveyors to come in, a grade checker that's running a rod with a 2D laser, the information has to go from outside the machine into the machine somehow for the operator to know where to cut that grade, like cut the grade to, or fill the grade to. And when you have all of that information inside of the cab for the operator to make those decisions, that individual or that survey firm are no longer needed for that task and can be allocated elsewhere. So the individual that was typically running the grade rod could get in another machine or be distributed off to some other task. And when you have a workforce that are not, people aren't running into the construction trades right now, really helpful to be able to enable the operator to do these things without having to have multiple people on that crew. Every time that surveyor comes out to the job, it's dollar signs. So the technology can equip you to do that. If you have a grade rod from a surveyor a grade stake from a surveyor that gets run over by a truck or hit with a machine, instead of having to, call them and have them come out to replace that, you can use your technology because you don't need that rod, that stake in the first place. So there's a lot of ROI just in the nature of that piece. But the accuracy and the productivity just of the operator not having to have that communication and knowing exactly where they're going to. I mean, we hear numbers like, I did it twice as fast. I did it 3 times as fast. We have contractors with many customer stories that have come back to us after making the plunge on the other side of their technology learning experience and said, I'm so glad I did this because I'm able to do 3 jobs in the time that I was doing 1 before, just because of how quickly I can come and start that work. And the amount of time that it would take to pull strings and figure out grade and people not showing up to the site. So there's a really great ROI story. And it really depends on kind of how much you use the technology to optimize your workflows. But we hear time and time again, and you and I have been touching on it, that piece, hey, I purchased the technology, but when am I going to find time to learn how to use this stuff? We hear that all the time. And just as our solutions, we aim to make them as flexible as we can. We want to make the way that the product gets to the customer as flexible as possible. And in steps are subscription offerings where you don't have to wait for that large job where the investment and time can be rolled into that big job that you won. But that investment can be spread and span across the year, and give you that flexibility. You always know you're going to have the newest tech. You don't have to hit that big lump sum investment at the beginning. It's spread it across the year to a more predictable billing cycle, and things like that. We're trying to help break down those barriers to entry. So it's typically hard to visualize the ROI until you've made the purchase, and that's a challenging message to drive to our customers. But the best thing we can do is work with the contractors that have used our technology and spread the word, because I mean, typically once they adopt the technology, they become very competitive in their local markets and do start picking up jobs that they weren't doing before. So they tend to be very vocal about that and reach out and telling us about how cool the tech is. And
Yeah, there's nothing like increasing your volume and then also having a tool that allows you to increase your volume without maybe having to increase your, all of your overhead. Anyway, obviously there's a little bit of overhead in the initial expense there, but yeah, no, that's very cool. I mean, and it's a kind of like a virtuous cycle there in terms of this thing is opening up the volume because it's allowing you to take on the volume without making a bunch more changes. The final thing that I'll hit on and ask you about before we head out is, do you have any tips, or maybe when it comes to like the picking a CTL to put this technology on, can you just go ahead and use it on your existing CTLs? Is there any kind of instance where you might want to consider buying a new CTL for this, or if you already, I'm gonna buy a new CTL for this because I want to use it more for that, so I'm gonna go buy kind of like a CTL with this in mind. What are some of the tips that you might have for what are the better types of, or configurations or specced out versions of CTLs that you guys kind of recommend taking a look at, or making sure you have a machine at minimum that has this type of configuration on it?
Right. Yeah, that's a great question. And one of the big things around that is again back to the automatics conversation. If you're looking for automatic control of your attachment, that's really where the machine model and type become a lot more prevalent in the conversation. And that's typically around the attachment, right? Because we're driving, the technology is driving the valves of the attachment automatically. And that's where, when you're looking to purchase a new attachment, looking for the manufacturer and saying it's grade control ready, and talking with a local SciTech dealer that has knowledge on which attachments have gone through the testing and onboarding into grade control solutions is a really good place to start. When it comes to Siteworks Machine Guidance, because it's entirely an indicate overlay system, it'd be hard to find a compact track loader that it wouldn't work on. So no worries there. But it really, when you start talking about that automatics, that's where each one is tuned and tested and onboarded by Trimble. And so the larger name brand ones are usually always covered, but when you get into this smaller attachment manufacturers, just talking to them and asking them, is this grade control ready? And they'll definitely know that, yes or no. And that's just that conversation you want to have when you're looking to buy that new equipment.
Yeah, absolutely. Jack, thank you so much, man, for hopping on. We're gonna let you go, get back to your day job. But again, thank you so much for hopping on and talking to us about CTL machine control, and specifically the details around the new Siteworks machine guidance module for compact track loaders. I'll give you the final word here. If customers have any further questions for you guys, where do they need to go if they want more information on any of these solutions that we've talked about today from Trimble?
Yeah, absolutely, Wayne. And it was my pleasure. Thanks for having me on. But yeah, if you have any curiosities about grade control, Trimble.com has a plethora of information, but feel free to reach out to your local SciTech dealer. They're our trusted distribution partner that are absolute experts on applying our technologies to every job. So reach out to them. And yeah, thank you so much, Wayne. Again, it's great.
Yeah, no problem. That's what they're there for. Jack, again, thank you so much. Appreciate it. Until next time, man.
Sounds good. Thanks, Wayne.